Hello, everybody. I hope you had a good spring break, but we have to get back to the chemistry, so let's just get straight to it. So this has to do with region 2 for the experiment 10 titration of a weak acid that we did. In region 2, we are going to be adding the base to the acid. Remember, our chemical formula is going to be NaOH plus whatever acid, HA, HX, whatever it is, and that is going to give us NaA plus H2O. And everything is 1 to 1, right? And also, just to make things clear, this NaA, well, we could just think of it as just A minus because this sodium is really just a spectator ion, right? If we were to write this equation as a net ionic equation, we would be writing this the way that you see it with the Na crossed out, okay? This is very important because this is going to help us determine the molar values that we're calculating later. But I just want to make that point very clear. This Na is simply there to hold the charge. Really, this is the net ionic equation without the NAs, okay? So the approach we're going to take is, number one, we're going to use the Henderson Hasselbach equation. So Henderson Hasselbach, forgive me if I misspell it, Hasselbach. And remember that the Henderson Hasselbach equation is pH equals pKa plus log of A minus over HA. And these values here are really going to be key. If you look at your Excel sheet, they actually have a column where you can calculate these values. And remember that both of these values are in molar, which is moles over liters. Moles over liters, all right? So we have to figure out the moles and we have to figure out the liters. Here's the thing. The moles are changing because we are adding NaOH, and every time you add NaOH over here to the HA, you're creating the sodium anion. In this case, I'm using acetic acid as an example, sodium acetate, and H2O. So to know the concentration of one, we have to know the concentration of the other, and we have to know whether they are reacting or whether they are forming. All right? So this is what makes this a little tricky, but as long as you're following this formula that I gave you here, or rather the just acid-base neutralization formula, it really should be straightforward. So please make sure you know your stoichiometry. That is the whole key to all of this. So again, Henderson Hasselbalch, and we're going to need the concentration of A minus or NaA and the concentration of HA, which is our acid, whatever it is. In my example so far, I've used acetic acid, so I'm going to stick to acetic acid. All right, so there it is. Number two, we need to find out what our concentration of A minus is going to be. So how do we get NaA? How does it form? Well, you are reacting your sodium hydroxide with your acid. Only when you react those two together do you form sodium anion or sodium acetate in this example. And remember that in this case, you are titrating the acid with the base. So that means that you are adding small bits of base to acid. In other words, when you add the base to the acid, the moles of acid should be going down, the moles of base should be completely disappearing, but all of your base is being turned into sodium anion. So the moles or the concentration of your A minus, right? Remember, this is moles over liters. Well, the moles of your A minus or your anion or your acetate are going to equal to your moles of NaOH that you've added, because the NaOH is being directly converted to sodium anion and sodium acetate. And so this takes care of the first part. What about the liters? Well, we started with 25 milliliters, I'm sorry, of acid, 25 milliliters of your acid. And in my example, at least, I was adding 1 milliliter at a time. So here I was adding 1 milliliter of NaOH per, what do you call it, specimen, something. Every time, every trial, every addition is 1 milliliter. You guys obviously had a different volume, so make sure you stick to your volume. So my new volume, when I add my NaOH, is now going to be the addition of the volume of NaOH I added plus my original 25. Okay? So as I create my initial amount of sodium anion or sodium acetate or just A minus, the volume is no longer 25, it is now 26 or whatever it is, 25 plus whatever volume you have. So make sure that when you are doing the calculation for bracket anion or the molar concentration of anion or the molar concentration of sodium anion, however you want to think about it, it's the same thing. Make sure that you are using the new volume, and I think there is also a column for that in your Excel sheet called total volume. So that's just the volume of NaOH you are adding. So how do we calculate moles of A minus? Well, the moles of A minus are just the moles of NaOH. How do we calculate moles of NaOH? Volume times molarity is going to give me moles of NaOH, which is going to equal to moles of A minus. And these new moles of A minus should be divided by, I'm going to use another color here, blue, your new volume after addition. So 25 plus it would be 26, and that will give you your new molarity of A minus. And this molarity of A minus is for every addition. So you add 1 mil at first, so you add a certain amount of moles of NaOH, then you add 2 mils, so now you add 2 moles of NaOH, etc., etc., etc. All you really need to do is type these formulas into Excel. All right, so I'll let you guys do that. I'm not going to go too much into detail, or the video is going to take 5 hours to make. Number 3, you also need your concentration of HA. This concentration is going to be going down because you are titrating the acid with the base. They are reacting together. So you have an initial concentration of your HA, which you calculated in the video for region 1, right? That is your initial concentration. Remember, once again, moles divided by liters. How do you calculate moles? Volume, which was 25 milliliters. Oops, sorry about that. 25 milliliters, 0.025 liters times your molarity of simulated acid, which was 0.100 molar. And that is going to give you the molarity. You're going to divide that by the new volume. In this case, again, remember, I'm referring you back to this area right here. You are adding volume of base to your acid at every addition. So make sure that you're doing 25 mils plus however many volumes you've added so far. And that is going to be your total volume. So it's going to be volume times molarity gives you moles divided by the new volume. So in this case, 0.026. And that should give you your new molarity. And you have to do that for every amount of total volume that you've added. So again, I'm not going to go through the details. I think you guys are familiar enough with this to kind of figure out how to go from there. But you're going to get a whole column that calculates your concentration of A minus, anion, or acetate, or formate, whatever it is you're using. And you're also going to get another column to calculate your concentration of HA, also whatever it is that ends up being. So far, so good. Once we have all of that, well, we know the log of A minus over HA. That's just going to be, you're going to plug into Excel the logarithm of A minus divided by HA, the concentrations, right? The pKa value, well, remember, I'm going to use another color here. Remember that your pKa is equal to your negative log of Ka. So again, using acetic acid as an example, you're going to have to do it with everything else. And all of these are formulas you can plug into Excel, by the way. I'm just showing you the math on how to do it. Your pKa is equal to your negative log of Ka. So for acetic acid, I think from memory, it's 1.8 times 10 to the minus 5. So if you take the negative log of that, you are going to get your pKa, which is going to equal to, I believe it's 4.74. Again, I'm remembering numbers. Make sure you check with whatever values they actually give you. So look, to calculate pH, we need the pKa. We have it. Using number 2 and number 3, we've been able to calculate the concentrations of A minus at time t and the concentration of HA at time t, or I should say at addition t, addition volume, whatever it is. Whoops, I don't know what happened there. And so we have all of the information to calculate our pH values right there. So you're going to make another column on Excel, and you're going to put pH, and you're going to have that equal to the pKa, which is just negative log of whatever number they give you, plus the log of, and you're going to put parentheses, your concentration of A minus, which is part of one column, your concentration of HA, which comes from another column, and that'll give you the pH up until the equivalence point. So this takes care of the entirety of region 2, all right? Again, I would love to go through some actual numerical examples, but that is going to make this video excessively long. And at the end of the day, my numbers are not the same as your numbers. So please make sure that you talk your way through this, consult with your classmates. But this is not something you haven't done before. It's also after the midterm, so you are definitely a little more familiar with how to achieve this. Just remember that in order to get the pH, you do need to use the Henderson Hasselbach equation, number one. Then you have to find out your concentration of anion at every addition volume. That is a simple moles times volume. Volume times molarity gives you moles, I'm sorry. And that gives you moles. And then from there, you just remember that the volume is additive. So this is all the information you really need for region 2. If you have any questions, please feel free to send me a message and I will get back to you as soon as I get the chance. I will be posting more about region 3, so thank you for watching and please be on the lookout for region 3 video.